Hello everyone. Welcome to the topic of logic in discrete mathematics. Today's lesson is about logic. What is logic? Do you use logic in your everyday life? Is logic important to you? Logic is the study of correct reasoning. Where can we use logic in our everyday life? In mathematics, logic is used to prove theorems. In computer science, logic is used to prove that programs do what they are supposed to do. However, there are a number of different types of logic that have been developed. In this course, we are going to focus only on the simplest form of logic, that is two-value logic. Are you familiar with this term? Propositions. So, what is a proposition? A proposition is a statement or sentence that can be determined to be either true or false. Let's try some of the examples. The moon is made of green peas.
Oh no. The moon is not made of peas. It's not right.
Well done. You said it right. The sentence is false. This means that this statement is a proposition, although it is not true. As we know, a proposition is a statement that can be determined to be either true or false. Now, let's try with another example. Petronas Twin Towers are in the capital of Malaysia. The statement is true. Petronas Twin Tower is located in Kuala Lumpur, Malaysia. Therefore, this statement is a proposition. How about with this last example? Have you ever been to Malaysia before? It is not a proposition. You can't determine whether the sentence is either true or false, because it is a question. Now, let's move on to another term in logic, known as connectives. Give your attention to the following symbols. As you can see here, there are four symbols which are labeled as A, B, C and D. These symbols are known as connectives. Symbol A is known as conjunction and symbol B is an inclusive disjunction, or symbol C is an exclusive disjunction, or symbol D is a negation. They are known as the most common connectives in logic. By the way, where we can use connectives. If P and Q are propositions, new compound propositions can be formed by using connectives. We use connectives to form a new compound propositions from two propositions. Now, let's try with a simple exercise. Say you have two propositions. Let P be the statement, tigers are wild animals. Let Q, Kuala Lumpur is the capital of Malaysia. So, try to find out the conjunction of P and Q. Brilliant! The answer is, tigers are wild animal and Kuala Lumpur is the capital of Malaysia. Let's move on to the next subtopic, the truth tables. The truth values of compound propositions can be described by truth tables. Here is an example of the truth table, of conjunction for two propositions, which are P and Q. These are statements. The symbolic form stands for P and Q. The first row says P is true, Q is true, and P and Q is true. The second row says P is true, Q is false, and P and Q is false. The third row says P is false, Q is true, and P and Q is false. The fourth row says P is false, Q is false, and P and Q is false. Let's try to construct a truth table for the given example. Masjid Jamek, Kuala Lumpur is accessible by car, but getting there by LRT is easier due to limited parking spaces. From the compound proposition, we may define a variable to represent each basis statement. Step 1. Use a variable to represent each basis statement. Let P be the statement Masjid Jamek, Kuala Lumpur is accessible by car, and Q be the statement getting to Masjid Jamek, Kuala Lumpur by LRT is easier, due to limited parking spaces. Then, write the given statement into symbolic form. The word but in the compound statement has the same meaning with and. Conjunction of P and Q as shown on screen can be denoted as P and Q. Step 3. Set up the truth table. When n is the number of proposition, for example, P and Q, as the variables, then the number of proposition n is 2. The number of rows in the truth table is given by a formula, 2 to the power of n. In this case, n equals to 2. So, the number of rows are 2 squared, which equals 4. Therefore, we will have 3 columns with 4 rows. 2 columns for the two variables P, Q, and the third column is for the conjunction P and Q. The first truth table is table of conjunction. So, what are the values for the conjunction of P, Q in the truth table? Try to complete the table, from left to right. Let's start with the first row here. When P is true and Q is true, then, the conjunction for these two variables is true. When P is true and Q is false, then the conjunction will become false. When P is false and Q is true, then, it will become false. When both P, Q are false, then the conjunction will become false. As you can see, we have one special case for conjunction that can be highlighted. It is when both variables P, Q are true. Next is the truth table of disjunction, which is given by the following table. Try to complete the table from left to right, and fill up the values for the disjunction of P, Q in the truth table. Let's start with the first row. Here, when P is true, and Q is true, the disjunction for these two variables is true. Do similarly to the following rows, and you will get the disjunction values for the second row, is true. The third row is true. And finally the last row is false. As you can see, the disjunction of two given propositions is false, whenever both statements are false. Otherwise, the disjunction is true. Now, we look at the truth table of exclusive disjunction. Exclusive disjunction are statements of the form, either P or Q, but not both. P exclusive disjunction Q is true, only when P is true, and Q is false, or P is false, and Q is true. Let's try for an example. Let P be the statement, I go to school by car. Let Q be the statement, I go to school by bus. The statement, I either go to school by car or by bus, means that, I go to by car is true, or I go by bus is true. In this case, both cannot be both true, or both false. Truth table of negation. Negation of P, in symbols is written as tilde-P. To negate a statement, means that, we make a true statement false, and vice versa. Negation of P is false, when P is true. Negation of P is true, when P is false. Example. Let P be the statement, I am going to Kuala Lumpur, Malaysia. Negation is the statement, I am not going to Kuala Lumpur, Malaysia. More compound propositions. Let P, Q, R, be simple statements. We can form other compound statements, such as the disjunction of P, Q, with conjunction of R. The disjunction of P, with conjunction of Q, R. The negation of P, or negation of Q. The conjunction of P, and Q, and negation of R, and many others. Example. Truth table of disjunction of P, Q, with conjunction of R. Let's fill up the first row. Now, when P is true, and Q is true, we know that P or Q is true. Since R is also true, we have that P or Q disjunction R, is true. We can complete the table in a similar manner.